Let's talk about some periodic trends. The first one is the trends of how metals, metalloids, and nonmetals are located on the periodic table. So recall from a previous chapter, it's this heavy step line that helps delineate where the metals and nonmetals are respectively. And the metals are on the left-hand side of this in the green color, except for hydrogen, which is kind of hard to see. It's in the crease. Here's hydrogen over here, and hydrogen does have one valence electron similar to the alkali metals. However, it has properties that would more likely fit a non-metal under normal conditions. So hydrogen is classified as a non-metal, although it's often considered to be a unique element. Now, nonmetals are on the upper right-hand side, or the right-hand side of this line, and they're in the purple color on this particular periodic table. So you can see just by looking at this colored periodic table that the elements are more abundantly metals than nonmetals. And then the peach colored on either side of the heavy step line, these are metalloids, and metalloids tend to have some properties of both metals and nonmetals and are uniquely used in semiconductors because of how they conduct electricity. Now, an important thing for us in this particular chapter to understand about metals and nonmetals is that metals tend to lose electrons. So when they lose electrons, they form a ion, and the loss of electrons forms a positive ion, or they form a cation, which is the name for a positive ion. Nonmetals, on the other hand, tend to gain electrons. And when you gain an electron, you become a negative ion, and negative ions are called anions. So one of the important ways that metals and nonmetals react with each other is by the transfer of an electron from a metal to a nonmetal. And that's going to be called an ionic bond, and one of the things that we're looking at in this chapter. So the other two types of trends are atomic radius, which is also, you can think of it as the size of the atom, and then ionization energy, which is the energy to remove an electron from the atom. And we're going to be thinking about the energy that it takes just to remove the one outermost electron. So let me change colors here of my pen so we can kind of get a different idea about these trends, so we can put them next to each other. So in terms of size, in general, the size of an atom as you go from the left to the right on the periodic table, in general, the radius decreases. And the reason it's decreasing, or how we can kind of explain it, is that in any given period you're all in the same energy level. And so as you go across the energy level, not only are you adding electrons, but you're also adding protons to the nucleus as you change from one element to the other. And so you have more positive charge inside of the nucleus, and so in that particular energy level, for example, in the second period, all the electrons would be going into the second energy level. They're able to pull those electrons closer because you're increasing the positive charge inside of the nucleus. So that's kind of how we can understand that they're getting smaller as you go across. Now when you talk about groups, I'm going to make my group also going decreasing, and as you go in a group, if you go from the bottom of the table to the top of the table, you also have a decrease in your size. So the size decreases. Now, to explain this, it's probably easier to go down a group, but understand that in the first energy level, you have the one energy level where your electrons are, and as you go down the table, you keep adding energy levels, which the orbitals then are getting bigger and farther from the nucleus, and that just makes your atoms become larger. So as it ends up, the smaller atoms are at the top of a group, and the larger atoms in general are at the bottom of the group. So looking at this trend here, if we look, the smallest atoms we would expect defined up here in the upper right hand corner. So these are the smallest up here. And then the largest atoms we would expect to find down here. These would be the largest. Okay, so that's one trend. So I'm going to change colors now, and we'll look at a different trend. So now let's look at ionization energy. So in general, a general trend in ionization energy, as you go from the left to the right, the ionization energy increases, which means it gets harder to remove the electron, or it takes more energy to remove the electron. Now this is not, when we say in general, it doesn't mean that every subsequent one is a little higher, but just as if you looked overall in the big picture, that as you go from left to right on the periodic table, the ionization energy, and I'm just going to write IE for ionization energy, it increases. And so then let's think about how it would go in a group. And so in a group, as you go from the bottom of the periodic table up to the top of the periodic table in any given group, in general, the ionization energy also increases. So basically, if we try to think about what that meant in terms of locations of the highest and lowest ionization energy, in this upper right-hand corner, we would have the highest ionization energy over here, and then the lowest ionization energy on the lower left-hand corner. Now if you think about this just for a minute, it makes sense. So a small atom, its outer electrons are very close to the nucleus, so it can feel the attraction of the pull of the protons in the nucleus. So it takes more energy to remove that outer electron because they feel the real pull of the nucleus. Where on the lower left-hand corner you have your largest atoms, and those largest atoms, the valence electrons, or the outermost electron, is the farthest away from the nucleus, and there's other electrons in between kind of blocking the pull that it feels from the protons or in the nucleus, and so it takes less energy for the larger atoms. So these two trends actually fit very nicely together. Small atoms, it would require a lot of energy to remove an electron because they feel a great pull from the nucleus, where large atoms, it takes less energy to remove the outer electron because it doesn't feel as great of pull because the electrons are farther away from the nucleus. So those are just a few of the trends that we can find on the periodic table, which has so much information for us.